G'day, let's have a look at what's inside this CyberPower PDU. So PDU is a power distribution unit. This is a rack mounted system, so this will sit in a rack server and it'll control the outputs of these 8 outputs, and it'll control them, turn them on and off. And also this one has metering capability, so it'll meter how much power each of those units is actually using. So a quick overview. It's a relatively small case. It's got a really nice finish on the outside, sort of a bit of a matte feel to it, and the whole unit's black. So on the back we just have a ground connection, so you can an earth connection, so you can just earth this. If there's any shorts or any issues like that, the power will go through this into earth. There's nothing else really on the top or the bottom. On the sides we just have a bunch of screws there to just mount some rails in. That'll actually then mount to the rack. And then on the front is where everything happens. Okay, so well, this is a brand new unit, so the little screen cover is still on there, so we'll just leave that on for now. But on the very left side here, we've got the input. So we've got the input coming into the unit, and then we have 4 sets of 2. So I think these are all actually individually switched. They're just mounted in these sets of 2, but we've got 8 outputs with LEDs on the bottom as well. So each of these LEDs will light up when that output is turned on. And each of those 8, you can individually turn them on and off, and also have that metering capability for them. On the right side of the unit, we just have 2 buttons, so to select and enter, they're just little tactile buttons. There's a little LED up the top here for normal operation, and then we've got warning and critical, so that'll be if there's any issues with it or if too much power is being drawn from the unit. We've got a little screen. It's probably just going to be an LCD screen that'll just display the information from this unit, and by pressing those buttons and also connecting to it through Ethernet here, you can change what's on that display. And then on the front, on the right hand side here, we just have a USB and a couple more connections. So we've got a serial connection and then just an out there as well. So this is how you connect into it to actually control it. That's pretty much it on the outside. So we just have, there's 3 screws on the bottom. I think there's a bunch of screws up the top here. So we'll dig in. All right, there we go. So this is just a bit of sheet metal that has just been bent into place. First, this would have just been stamped to cut it into shape, and then just bent at these right angles here, just these 2 bends. So that's just the front cover that pops off, and then we've actually got the electronic unit. So there's actually a couple more screws on the front here, so I'll take this off as well and have a look in there. Alright, so this whole front little screen and control assembly here, and we've got a couple of PCBs and a little ribbon cable connecting it to the board inside. So all of that just pops out with these 2 screws. And I think the reason they do that is because if this is in operation and the control board fails, you can just take this out, unplug it here with the connector, and replace it without actually having to take this whole thing out, unplug everything, and so on. So since we're here, we may as well actually just have a look at this. All right, there's just got a couple of PCBs to it and then this connector. So I'll take it off and take this apart and have a look. All right, so I won't go digging in through this too much. Actually, I'll take this little plastic cover off here. I just don't want to break any of the terminals because I think it's all just soldered straight into place. And this is brand new and I want to use it, so I don't want to go damaging anything. But on the back, that's actually really interesting. We've got a battery on the back, which would imply there's probably some volatile memory in there, that battery is there to keep on. Interesting they didn't use maybe flash for it instead. Now, I'm just looking at this. So either way, this is the front. We've got all of the inputs here, and then we've got the screen and a couple of layers of the PCBs there. So this is going to be the brain box of the whole thing. So a couple of just tactile push buttons in there. We've got a little speaker in there as well. So this unit it's a piezoelectric speaker, so the unit must obviously beep. And then this front PCB here just seems to have all of the IOs on the front here, everything connected to it. The screen also runs to the bottom of it, and a couple of microcontrollers there. It's interesting actually we've got these headers inside. So those ones, I think they're just the standard IO headers that are soldered straight onto this bottom board and then pushed through and then soldered onto the top board as well. So that's how the PCBs communicate between each other and are connected together. So I think that would really just be the output from this bottom board onto the top to display it on the screen, and then it would just be the input for all these things that would do a little bit of processing and then pass it onto the bottom board. The reason I say that is because the bottom board here has this microcontroller here, and then we've got another one, another quite big one there. I'm not sure, they should be able to see that. Another big one down there. So that's going to be the brain box of the unit. These guys will just be doing all the processing there, sending commands up to the top board, receiving the inputs, and then also through this ribbon cable here, going into the main board, which I assume that's probably just going to be for the relays to actually turn those outputs on and off, and also for the measurement of that. So just do another quick close-up of that. Put that aside and let's have a look at this main board here. All right, so I just had a good look at that. So we've got the power coming in from the input on the side here, and then we've got live and neutral that go onto another board, but ground or earth goes straight onto the actual case of this. And then also there's another one that gets passed on to these other IEC connectors, so to the center bit there as well. So that ground there will just get passed on to all these other bits here, as well as the whole case. So that's good to see the whole case is just earth. So if there's any shortage, any short circuit or surges, that'll just go straight to the earth and protect anyone touching this from actually getting electrocuted from that power actually going through the person to complete the circuit. So we've got those two live and neutral coming into this board here, but you can't really tell what it does. It doesn't seem to do too much except for split this power. It does have a little microcontroller there, and that goes onto this other board here, which then goes onto this board, but the front screen actually connects straight to this board here. So I think what we've got is, this here looks like there's a little transformer there and a common mode choke and a bunch of capacitors. So this will be just transforming the voltage, so going from that high voltage to a low voltage to supply the front computer with a lower voltage. And these guys here are relays, so see if I can see a voltage on them, because these relays might also be 24 VDC, it says that on there. So if I can bring that closer, you can actually have a good look at these. So these white things here are just the relays, and that's what's going to actually be turning on and off the power to each board. So actually some of them are reversed. That was just the reverse one. So this one here, you can see that's the right way up. So just here 24 VDC, 16 amp, 250 volts. So what I was saying before is I don't think these are actually individually metered. I think I got that wrong. I think there's just one meter for the whole thing that's actually taking the measurement. So I think the power is going into this board here, and then on this board we've got a little sensor there, and that's going to be just measuring the actual current that goes through this. From here we've got the high voltage going straight onto this board here with the relays, and then those relays will just be turning that on and off for the individual ports. So again, we've got 8 ports, so we should have 8 relays. So 2, 4, 6, 8, yeah. So 8 of these white relays here to actually turn that power on and off. And then as that power comes into this board here, this connector here will also take it to this other board here. And this board here, as sort of said, is just going to be stepping down that voltage for the brain box and for those relays. So as this is then 24 volts, so that should get past, there's probably going to be a couple of different voltage levels that this actually does do, because we're going to have 24 volts for the relays, but I would imagine these electronics would work on 24 volts. They usually do 5 volts or even 3.3 volts for some of the more sensitive electronics. So I think this board here would step it down a couple of times and we'd have a couple of different voltages, so that either 3.3 or 5 volts is going to be coming from this board through this connector onto the front circuit and actually connecting onto this, and that's just going to be all the control logic again. And then we're going to have the 24 volts that'll pass through this cable here onto the actual relay board. And then this board here hasn't got all that much to it. It's really just going to be taking the inputs that it receives from the computer or from the control board, and then just switching these relays on and off using that higher voltage as well. So there'll be a bunch of transistors there that'll actually be doing that switching. That transistor will switch the relay, and then the relay will turn on the main power coming in from this main board. So what I was saying before is up here we've got this green it's quite a solid wire actually. It's a really thick wire that actually gets soldered in. So we've got that green there, which is going to be the earth. It just goes from the left side here all the way across the other side. And we've got the same with that neutral there as well with the white. And the brown is what's going to be the live one, and that's what's getting switched through these relays. So it's actually pretty simple. We just have a power meter board, power sensing board, the actual voltage step down for the control board, and then we've just got the actual relay board as well. So that's pretty much all that there is to it. I can't also see any parts that are redundant in this. Some of these boards or some of these PDUs will have a redundant power supply or a redundant power board as well. So if anything does fail, this can still stay in operation. But it just depends on how these relays will fail, because if a relay does fail, this might either just stay on or actually break that circuit and turn whatever the device is coming out of it that's off. But that's it. That's what's inside a pretty standard, commonly used PDU. So thanks very much for watching and have a good one.